Hey, good afternoon, everybody. Jim Warren with TXAPA. Welcome to TXAPA Live. We are glad to have everybody here with us today. Going to be a great show today. We're continuing our program on fundamentals, and we have the incomparable, the innumerable, the man himself, Chuck Fuller, TXAPA's ambassador for quality, here to talk about mix types today. So, Chuck Fuller, welcome to TXAPA Live.
Thank you, Jim. And I really appreciate that introduction. It really does mean a lot coming from you, So for those of y'all that haven't noticed, I have my Jim Warren haircut. Not on purpose. It was my fault. I accidentally gave my wife the wrong clipper size. So, but hey, it grows fast, so I'll be out there.
You gave your wife a tool.
Gave her the long clip. My fault. So
sorry, Saber.
Yeah, it was my fault all the way. I'm not going to blame her on that one. So, but anyway, thank you, Jim. I really appreciate being here. So, absolutely.
Let's get started.
Yeah. So we're going to talk about the asphalt mix types out there. Okay. So in the fundamentals that we've talked about earlier, we've already gone through aggregates, right? That's the first one we went through. We went through how important it is to have certain aggregate characteristics. We have tests on all the aggregate, right? We know that we need to have that aggregate structure to be able to work correctly. And then the next thing we went through was the liquid AC. Okay, we're really important. When you modify your different liquids and you modify your aggregate structure, you can make really good, durable, long-lasting pavements. So we have those two put together. And then now we're going to talk about the different types of mixes that are going to be incorporated with the aggregates and the oils and what they can do and where we need to place them for. Okay. So again, the definition of asphalt pavement is simply a mixture of asphalt binder, graded mineral aggregates mixed at an elevated temperature and compacted to a uniform density. That's the definition of asphalt pavements. And again, we're talking about 5% binder, 95% aggregate. And it's real important to know that we can use these aggregates or this asphalt pavement in all sorts of structures, okay? Highways, airfields. I want to reach out to Austin Bridge and Road. They just got finished completing the second phase of the DFW airport in flexible pavements.
Awesome.
So we know that, this is the busiest airport, one of the busiest ones in the United States, and they're made out of asphalt pavements, okay? So we know that we can do that. We know that we can do, again, parking lots, highways, airfields. And again, this slide is so important, okay? Because it's very important to understand the basics of what asphalt pavements are. And again, it's mineral aggregates, it's asphalt binder, and it's air voids. And Buddy Williams, thanks a lot again for reminding me that we cannot forget the air voids. Never going to live that down. Really appreciate that, Buddy.
Air is important.
Making me feel good about myself for forgetting that. But it's only 3 components, okay? And granted, I only hit the 2 earlier, but it's only 3 components. And air voids, asphalt binder, and mineral aggregates. But it's how we put these things together. So what is asphalt pavement? What is asphalt pavement? Asphalt pavements are engineered mixtures that require the right balance between component materials as well as an understanding of the climate, traffic needs of the community, which the pavement serves. Always designing for long-lasting performance, and producers must take a balanced approach to include RAP in their mixtures. This is so important to understand the climate and traffic needs of where we're putting in that. Let's design accordingly to what we're trying to achieve and not design to a budget. That's very important to all you design engineers out there. If we are designing to a budget, we're not going to get durable, long-lasting products, right? So we have to design to what our climate and traffic needs are, and that's so important, and that's the basis of where we're going to. So we're going to kick this thing off by starting with our very first one, which is our dense graded mixes. And this is our items 340 and 341. That's the old TxDOT items. And now we have a new item called 3076. Okay, so materials and tests have worked diligently over the years to establish a new specification, and it's 3076. Again, we can utilize dense graded materials in a wide variety of applications: new construction, rehabilitation, maintenance, low to high volume roadways, base, intermediate, or surface course.
Pretty much anywhere.
Anywhere.
Yeah.
So when
this
I
is
say
an all-purpose mix generally.
Yeah, absolutely. So
Yeah.
when I say low to high volume roadways, how do I get this material to work in a high volume roadway? Aggregate structure and modifying on my material, modifying my AC material. That's how I get it to operate, or how I get it to be able to work in these high volume roadways. Again, some additional information. These mixes have been around forever, for way more than 50 years. And we're currently using the super gyratory press, which again is going to help with our increase of liquid AC. Okay, some of the advantages. We got the initial lower cost. Okay, so out of all the hot mix items, our dense graded mixes, 3076, are typically our lowest cost mixes. And the reason that is because, again, producers and contractors produce this mix every day. They lay it every day. They've been doing it every day. They feel very comfortable. There's not a contractor out there in the asphalt world or a producer that has not produced or placed this mix. Okay, this is the most used mix in the state of Texas, both with TxDOT and the commercial side. And we can also use high percentages of recycled material. Here's a picture of some really good. This is a tight D dog, 64 minus 22, laying in, and you can see how uniform it is across the mat. That little arrow there, I want to stress to everybody is that is a good looking joint.
Absolutely.
And look, what's the raker doing, Jim?
He's not raking the joint.
Not raking the joint. He's not pushing the joint. They have the paving machine set up correctly. That's how you get a joint like that. You get your automatics, you get your joint match, you get all that stuff set up correctly. And that raker, is not raking a joint. He's
got a purpose.
He does.
But this isn't his purpose.
But this isn't the purpose. He has a purpose, but this isn't the purpose. And also, do you notice who's on the screed? One guy over there on that one side watching the curb line, right?
Yep.
So they got the paver set up correctly. That's most important. And look at this. Look at that joint afterwards.
Purdy.
That is just a good-looking joint. It's perfectly matched. It's perfectly done. Uniform mat. A great mix. I guarantee you this item 3076 right here, type D dog, it's going to be here for 15 years without any kind of issue whatsoever. Again, produced correctly, placed correctly. That's the two main things here. That's very important to know. The next section that we have permeable friction course, PFCs. Some of you individuals might know this as open graded friction course, OGFC, but TxDOT, we utilize permeable friction course. We have an item 342. We're in the process of revising these specifications and coming out with a new spec book. So I imagine that we could have some different specification numbers later on. But currently, right now, we're utilizing 342. And PFC mixtures are used on surface course only. That's what they're used for, surface course. They need to be on high-speed roadways. When we say high speed, we're talking 40 miles an hour or more. And why do you think that is?
Not a parking.
Not a parking lot. Why do you think that is, Jim? Why do we think we have to be 40 miles or more?
Well, you want it to where you're not going to create a hydroplaning situation.
Right.
And hydroplaning generally only occurs at higher speeds.
That's correct. Absolutely. So the standard PFC mix contains a 76 minus 22. And a reason for that, again, it's engineered. That's an engineered pavement, okay? 76 minus 22 with that aggregate structure is going to give us something that's going to let the water flow through and yet give us a good surface to be able to ride on. In other words, reduce that wet weathered accidents, increase that skid resistance, decrease the noise coming out of it. Overall, it's a great product, but you can't use it everywhere. That's the main thing. It's not a silver bullet. You have to engineer it for the correct usage.
And you want to make sure you use the polymer with that.
Absolutely.
You got to use the polymer with that. Yes,
it absolutely has to have it. And we have this discussion quite a bit about using asphaltic rubber and AR PFC. That's usually used on top of concrete, but we've successfully used different types of materials to be able to bond that PFC to concrete. And again, it reduces that noise reduction. And when we're overlaid, and it's way more quiet than dense graded mixes. Again, it's not a silver bullet, but it is a great surface mix to utilize when you engineer it correctly. So you pavement design engineers out there, Look at that. You got to be engineered correctly.
Great tool in the toolbox.
A great tool in the toolbox. It's high permeable. In other words, water goes through it. We have high asphalt binder. We have high asphalt binder. And the reason we have that is because, again, we want that coating all the way around. Lower the noise as compared to dense graded mixes. Again, it's porous. It reduces splash, and it's best applied in fast, continuous traffic, not in a big stop and go area or big curve areas. And the reason for that is, again, it's got to be engineered correctly to be able to work. So you can see here, hey, it's pouring right through there. Water is going right through there. You can see that that's what it's designed for. It works great. And again, it's a tool in the toolbox. It has its use. You can see here, this is a reduction in spray, and it's also, it's a reduction in spray, but it also helps with that undercarriage. So that water that's being splashed underneath your car, that's not happening, which helps reduce the amount of solvents, metals, and oils that go into the pavement structure.
That's a good point.
Yeah, so PFC's got a lot of good points to PFC. So again, you guys out there in the design world, that's a great tool. Superpaves. Let's talk about Superpaves. It's text dot item 344. Now, new specification has just been revised. So now we're talking it's 3077.
That came out January of last year.
Yep. We've had about a year underneath our belt with the new specification. And again, it's a great tool and when engineered correctly. So Superpaves are medium to high volume roadways or any roadways, exactly. Superpaves are a dense graded mix, okay? When we talk about dense graded mix, the 340, 341, Superpave's a dense graded mix. Superpaves, but you have to use a Superpave gyratory press to make them. You can use them in base, intermediate, surface course, reconstruction, new construction, overlays. Again, it operates and acts like a regular dense graded mix, other than we have some parameters that we have to utilize with Superpave. That is the Superpave gyratory press, and with the new specification, we have gradation areas that we have to work with. Give it more durable, longer lasting life. You have a stone-on-stone contact. It's highly resistant to rutting. Superpaves are really great with that. And when you get that stone-on-stone contact, the specification tells you that you have to be above the reference zone. Get the stone-on-stone contact, gives you a little bit more AC, and it gives you a high skid values and benefit to wet weather accidents. So Superpave is a great tool in the toolbox, again, to utilize. So here's the Superpave. Again, we no longer have Type A as an apple, whether it's in the dense graded or Superpave. There's no longer the Type A available to us. We have Superpave B, Superpave C, and Superpave D, D as in dog. We got some BMA requirements on it that are considerably high, which is great. Let's get that void in the mineral aggregate.
And we're getting more asphalt in the mix.
Get more asphalt in the mix. And again, the aggregate structure with the correct modified oil can hold the pavement structure, can hold up to just about any easels that we have out there. Okay. Again, design, engineered. This is Superpave C as in cat. Okay. This is Superpave C as in cat. This happens.
Ow.
Yeah.
Nice looking asphalt.
There it is. C as in cat. That's for Jenna out there in the world. But C as in cat, it's a Type C. It's a 64 minus 22. Again, as you can see, this is a farm to market road, right? This is farm to market road, Superpave C, 64 minus 22. The engineers determine what the easel loads, determine what the future easel loads are going to be over the next 5 to 10 years. And then they came up and they, utilizing their design criteria, came out with the Type C as in cat, 64 minus 22. So it's going to absolutely, again, durable, long lasting. It's going to be there 15 years from now.
Yeah, great looking texture on that roadway. Nice.
Great looking. Our next item is SMAs, Stone Matrix Asphalt, SMAs. It's item 346, again, text dot item 346. Now listen, Stone Matrix Asphalts are really, this is a great tool. This is a surface mix. We can use it in an intermediate layer, but typically we utilize it in a surface mix. And the reason we do that is because, again, it has the Sac-A rock. It has that structure that we talked about, that Sac-A rock, that high skid value rock. It has the 76 minus 22, and we have to have fibers in it. So you have to have all that. And typically it's on high volume roadways. Again, you can see this, you can see in the cutaway there that it's stone on stone all the way, right? It has higher binder contents and requires higher quality aggregate. Okay, so with that being said, it's going to increase the cost of that. So SMAs are going to cost you a little bit more than super paves or dense graded.
But you're putting it in the right place at the surface where you've got the highest stresses, and that's where you need it. And that's makes it worth the money to make that investment on those higher volume roadways. Absolutely.
Absolutely. I agree with you 100%. It provides both excellent rut and resistance to crack. I mean, it almost looks really oily, and it does. It has a lot of oil in it. There's very little fines in it at all. It's mainly stone on stone. Okay, you can see, you can just look at that cutaway. It's, it's stone on stone all the way through it. And then we call this the Cadillac of mixes. So it's been proven to 20 to 30% increase in the pavement life. And Jim asked me about this, and I pulled that out of some literature that NAPA had on SMAs. So it is a very durable mix. Again, because of the fact that you're using that Sake rock, and we're using that stone on stone, and we're using that 76-22, that modified oil with fibers, it's going to increase the cost, okay? But again, it's well worth it when used in the right spot. So here's some SMA, looking at some SMAs. That one with the dime on it, that's an SMA-F, as in Frank. It's a fine graded. The Odessa district uses a lot of SMA-Fs in their, as a surface mix now in their district. They utilize a lot of AR up there also. Mm-hmm. But again, it's a very durable surface mix. And again, looking at these cutaways and looking at these, man, look at that stone on stone. I mean, it is just really and truly going to be a good, durable aggregate structure with modified aggregate or a modified asphalt in it. And you just can't ask for anything better. But again, it's expensive. We want to utilize it in the right spot. You don't want to use it on a farm to market road when there's only three trucks a day go through it. But utilize it where it needs to be. So look at here. We've got an SMA surface core. So this is a full depth project. So we have on the right hand side, that's the surface mix on a SMA project. And you can see on the left hand side, we got the curb and gutter.
That's not in the wheel path, is it?
You mean the joint?
Yeah.
The joint in the wheel path? Good catch, Jim. So the joint is not in the wheel path. So what they're going to do when they put the final lift on the far left, there's a 4-foot bicycle lane.
Oh, okay.
So they're going to, when they restripe it, we're going to put a little bicycle lane on that.
So it's going to shift
over.
All right.
So that's the most important thing about laying it out, is that we do not want the joint in the wheel path. As a matter of fact, the new specification says what, Jim?
Don't put a joint in the wheel path.
Don't put a joint in the wheel path.
And here's a little tip to anyone ever wanting to put a pavement in for a TXAPA pavement award. If you put it in and it's got a joint in the wheel path and Chuck rates it, he will disqualify it. So don't do it. Hey, a real good tip there is use the final striping layout to determine where your top joint is, and then offset your way down from there. That'll make sure you get the joints in the right place.
You got a good point there. Use the striping plan to figure out your final layout. That is a great point, Jim. But absolutely.
Well, actually, I got it from you. So.
Well, I'm telling you.
I do listen. I do learn a little bit around this place.
If I find a joint in the wheel path, you are not winning an award, okay? You do not honor the pavement, in my opinion, okay? I'm just saying.
Well, you think about it. That's we're loading on the weakest link,
yep.
And we certainly don't want to do that. So we always want to make sure our wheel paths are in a sound structural area. And you want to offset those joints so they're out of that. Not just because you can win a pavement award, so the pavement can perform properly.
Absolutely. It's all, and again, that's engineered. It's engineered pavement structures. Then overlay mixes, TOM mixes. A lot of people have used these. A lot of people ask about them. I don't want to say they're fairly new. We've been using them for a while now. But the TOM mixes, TxDOT item 347, is a high performance overlay that's used as a pavement preservation tool. Okay, it is used as a 3/4 to 1.25 inch thickness. In the Austin area, Austin district, we use a lot of 70 minus 22, but most of the time mixes are utilizing a 76 minus 22. But if you notice, they're both modified. So you really need to use a modified oil with that aggregate structure. Again, modified oil with the aggregate structure to get the most use out of this. They are used for a pavement preservation tool. We can use them on any roadways. This material is very crack resistant. I mean, it's very flexible. Mike Ariano in the Austin district has a little deal where he's bending it almost to a 90-degree section, one of the cores. So it's very, very flexible. We have high percentages of asphalt in it. Okay, it's up to 7%. So if we're running a Tom C, as in coarse cap, it will have 6%, and a Tom Fine F, as in Frank, it's going to have 6.5% minimum asphalt. Okay, very durable, very flexible, stone on stone again, high skid values. Again, stone on stone, and the smaller the aggregate, the larger the surface area, right? Smaller the aggregate, more surface area, so we have a really good skid values. Again, we reduce the noise decibel considerably, and you can really improve a ride on an existing pavement structure with a TOM mix, a thin overlay mix. So again, when we engineer it correctly and utilize it in the right spot, what do we get? We get high performance, durable, long-lasting roadways. So let's look here. Where do we not want to put it at? We do not want to put it up there in the top left-hand corner where I have excessive patching or failures. We do not want to put it on structural deficiencies, like in the wheel path or on the outside edges. We can put it there, but you have to make those repairs first, okay? The best place to put it at is where you have block cracking, as long as the crack seal isn't over-banded. In other words, the crack seal is not over, doesn't have a lot of crack seal material up into it, and on raveled seal coats. I can't tell you how many times we used it on raveled seal coats and really have increased the ride. And also when you put it on ravel seal coats, you know, when you have a ravel seal coat, you have a wet weather accident fixing to happen, you know, because you got that oil exposed. And again, if you have minor longitudinal joints, again, if the crack seal is done correctly, it works perfect there.
So the pavement is structurally sound. It's not failed. And so we're trying to just extend the life of the pavement while it's still in good condition before it gets too bad. And the pictures that you've got, the X's up there, show, hey, it's gone too far for this kind of mix, or let's go in and let's fix it first, and then we can put this over the top.
Absolutely. Okay. That's exactly right. We definitely need, and we have tests to determine whether or not it's going to hold up. We have ground penetrating radar. We have following weight deflectometer, and then we have the visual test. I think we're all attuned to the visual test, which we know not to put it in those structural deficiencies. And here's a big one, guys. Don't ever put it on flex base. Do not put it directly on flex base. You'll have a failure immediately, okay? Some contractors have done that, trying to, you know, maybe do a detour or something like that. Don't do it. It won't work. It'll cause a failure, and then you'll say that TOM mixes are no good.
Again, putting the right mix in the right place.
Absolutely. Yep. And you know where to put it at now. So there's no excuses. we told you, don't put it there. No excuses. But this is what a TOM mix looks like. Look how pretty that is.
Nice.
Man, it is nice. Now, don't get me wrong. It's hard to shovel, hard to rake.
Probably pretty gooey.
You don't want to rake or shovel it. Yeah. When it comes out the back, that's what you get, right? And we don't want to vibrate it. We just want to roll it with a regular steel wheel roller just to seat it, just like you do a PFC. Okay. And it really is a great tool.
You're not measuring density on this material.
No, you know what? Bring up a good point. What do we measure? We're measuring water flow. So we want to make sure that we get it somewhat seated to where it's going to stay there. And what we do is the permeability test, the reverse permeability test that you do on a PFC.
Right.
So, by the way, you teach that in your inspector training course?
We tell them to run it. Absolutely.
So,
hey, since you brought that up, hey, for those that don't know, we're running this inspector course, and we've run 2 of them off already. We've got one coming up in April, one coming up in May. Those are sold out, and we were trying to think what we were going to do. So what we're doing, we've added another inspector training course, and it'll be on Tuesdays and Thursdays for the first 3 weeks of May. If you go to texasasphalt.org and get there, you'll get a link to the information. We had it on the information before the program started. So if you're still interested, we know we had some people that still wanted to get in. We've added another course, so we'd love to have you guys. So texasasphalt.org, click on the Inspector Asphalt Education Program. We've got one course left this spring, and then we'll be back in the fall.
Great point, Jim. And I know that you go through all the stuff with the aggregates, the oil, and then our mixed selection type to give those inspectors the knowledge of what they're dealing with, right?
Yeah, we've even had to add time to the course. We worked 2 hours a day for 6 days. Now we're 2.5 hours a day just to make sure we can cover all the material. So yeah, there's a lot to cover, a lot of stuff going on.
Yeah, and we're kind of flying through this also, guys. I mean, again, we only have really 30, 35 minutes or so. We're flying through this. If you have any questions, if you have any comments, please reach out to Jim or I, and we can answer these, okay? I'm flying through it pretty quick, but it's going to give you an overview of what we need to do and how we need to engineer our pavements. Thin bonded friction course. This is our last one. It's item 348. This one is used as a surface course only on high-speed roadways. It's placed in thin lifts, starting with 3/4 of an inch, okay? Thin bonded friction course, which is TBFC, includes an application of a polymer modified emulsion just prior to the asphalt coming onto it.
So that's the tack.
That's the tack.
Or the bond.
Yeah. Yep. And spray paver, that means it requires the use of a spray paver, okay? So thin bonded friction course is recommended in lieu of a PFC when item 342, that's PFC, is placed directly on an overlay of an existing concrete roadway. Again, utilizing different types of material to bond that surface course down. So thin bonded friction course have an initial higher cost, again, because of the fact that we have such high asphalt contents and we're using Sac-A rock. But yeah, they're thin, 3/4 of an inch. They're utilized as a surface mix. Again, another great tool to utilize in the toolbox. There's 2 different types of mixes, but there's actually 3 total mixes. Because
wow, that's a little confusing.
It's a little confusing, but let me walk through it real quick.
All right.
We have a thin bonded friction course. We have a PFC fine and a PFC coarse. It's the same gradation as item 342 PFC that we just talked about.
Okay.
It's the exact same gradation, same mix design type, except that you have to use a spray paver to put this down.
So that's the application.
It's the application.
Okay.
And then we have one called a thin bonded wearing course. And it is also permeable, but not as much. It only has like 8% air voids.
Okay.
And we're using less binder, okay? And we have no fiber or no lime. In other words, we're not using any kind of admix, okay? So there's 2 different types of mixes, but 3 total mixes.
We're trying to improve the friction characteristics of the roadway, but not spend a lot of money really structurally beefing it up.
That is correct.
Okay.
Absolutely.
Okay.
I believe Robert Lee said that the thin bonded wearing course, is the poor man's SMA. So essentially that's what we call it. So that was Robert Lee, that was not me. But anyway, thin bonded wearing course.
He'll be in next week.
Yeah. We have the advantages is, again, you can place it on concrete, utilizing that high polymer membrane. It's high-speed surface course. It's great for wet weather traction, and it reduces the noise. I mean, in urban areas, we've been known to not have to put such high sound walls up, okay, when we utilize PFCs and thin bonded wearing course, okay?
That's a big deal as Texas continues to grow.
It is. It sure is. Here's a spray paver. We got a ton of different spray pavers out there. You know, we used to just have one brand, but we have a ton of them out there. And again, they all work the same, and that is that they spray the membrane right in front of the asphalt going down. Okay, so it's a great tool, another great tool to utilize in the toolbox. Again, as a surface course, you can't go wrong with it. It's a great surface course.
So it's a distributor and a paver in one.
Good. That's a good analogy.
It's a twofer.
It's a twofer. It's a distributor and a paver in one. Great analogy, but it's exactly it. That's exactly it. That new one, the spray jet up there, that's a brand new model that just came out. I don't even know if we have any here in Texas. I think Austin Bridge Road might have one, but it's a good. So here's Beltway 8,
pretty.
okay? And if you notice on the far left-hand side, they have the sound walls there. So it was a concrete section of roadway, and it was just so loud that you see the neighborhoods there, right? You see the sound wall? It just went crazy loud. We came in there, or contractor came in there and did this thin bonded friction course, PFC, I believe. And look at that. Look how beautiful that is. And it just decreased the noise value, unbelievable, increases the ride, actually makes concrete ride smooth, just saying. And
there you go, it fixes it.
Just saying. And if you want concrete to ride smooth, put asphalt on top of it. So again, design engineers, remember that. It's okay to put asphalt on top of concrete.
Absolutely.
If you want it to ride smooth and be noise reduced, just do asphalt on top of concrete.
It's the Oreo method.
It's the Oreo method.
Yeah.
I love to show this slide because, again, as we go from a dense graded to your specialty mixes, you're increasing that asphalt content. Now listen, just because we're increasing the asphalt content doesn't necessarily mean it's better. If I put 7.2% asphalt like you see in the Tom F there on the far right, if I did that over here to the dense graded D-Dog, we would have rutting. We would not be able to have durable, long-lasting pavements.
Yep.
Each one of these materials has an aggregate structure that's going to utilize the amount of asphalt for it to be able to work correctly. I can't stress that enough. You can't put 5% AC in a Tom mix and expect it to act or work correctly. And you can't put 7% AC in a dense graded mix because it will rut.
It goes back into what you originally said. These are all engineered mixtures, and they've got to be properly put together. And there's a technique and a methodology for these, and there's a proper application for each one of them.
Absolutely. And it's a combination, okay? It's a combination. So we can combine Superpave or dense graded, then put an SMA on top, or we can combine Superpave, SMA, and put a PFC on top. A lot of 35 coming through Central Texas has an SMA, a 2-inch SMA with a 1-inch PFC on top. And again, when we start having issues with that surface mix, we can mill it off and overlay it and be good to go overnight. So that's the main thing I wanted to stress. Again, TXAPA, hey, we're dedicated to quality. Again, I'm gonna reiterate that safety number one, quality number two, and that's going to go into production and bonuses. Michael Lee has expressed that quite a bit. I'm a believer in it. Michael Lee has definitely made me a believer. If we really and truly make safety number one in our lives, and we make quality second, then all of that other stuff is going to come into play. That's going to be your production. That's going to be your bonuses. That's going to be long-lasting, more durable pavements. Mm-hmm. But we have to, again, I can't stress this enough, we have to do it safely, and we have to have quality. And who's responsible for safety, Jim?
Everybody.
Who's responsible for quality?
Everybody.
Everyone. It just goes hand in hand, and really appreciate Michael Lee and everything he's done for TXAPA. Can't stress enough. And if there's any questions, if there's anything that comes up, I'm a little bit over. I got 34 minutes. Jim put a clock in front of me, but hey, I'm here to tell you.
It's just a hint.
If you have any questions, please do not hesitate to call Jim or I, and we'll do the best we can to answer. And if we can't answer it, we'll ask Bill Weezy.
There we go.
I heard Bill Weezy was on the line, so we'll ask Bill Weezy. He knows more about all this stuff than all of us put together. Bill, again, appreciate the fact that you're out there. Appreciate the friendship. Appreciate everything that you've done for us. Really do. So, Jim, that's it for me.
Hey, great. Thank you, Chuck. We really appreciate the expertise and the explanation. We had a number of questions today, but trying to run the board and interface with Chuck and keep him straight, I just didn't have time to get to everybody. So if you didn't get your question answered, go ahead and contact TXAPA. You can email me at jwarren@texasasphalt.org,
Right.
and we'll try to get the answer for you.
Absolutely.
And we'll go there. Hey, just real briefly, next week we've got a redo, and not a redo, a makeup for when we had the what do we call it? Snowvid or the
snowvid?
The ice capades, or the Central Texas ice capades, or the whatever we had a couple weeks ago or a month ago. And Robert Lee was on board to do how materials and mix designs affect friction. So Robert's going to come back and spend some time with us next Thursday at 3 o'clock on May 1st. And it's not April Fool's that he's coming back, but we'll be glad to have him. So in the meantime, thank you for attending. Thank you for participating. Thank you for being part of us. And if you see any other things that you'd like to see, or hear any other topics that you'd like us to cover, please let us know, and we will do that. Chuck, you got anything?
Yeah, one more thing. So I know Robert Lee's coming in April the 1st to talk about design and friction, and it's kind of out of sequence. So go out there on YouTube channel and go look at Richard Izzo. Richard Izzo did a whole thing on aggregates, okay? Yep. And then you kind of put everything together. You could put my fundamentals with the liquid, the aggregate, Richard Izzo. Robert Lee was supposed to be there, but the ice event hit, and then we jumped into the mixed selection types. So you kind of got to put everything together to put the puzzle together. Go out there on YouTube, look at those up. They're only 30 minutes. Go through there, get acquainted to the aggregate, to the asphalt, to the Richard Izzo. And then we had Ted Flanagan, we had Tom Flowers on talking about liquids, and then Robert Lee. Boom! You have a whole right there. You got the full sandwich. So full meal deal.
Well, full. We're not going to supersize it. But Chuck, one more real quick critical question is: you've talked about the binder, you've talked about the aggregate. When are you going to talk about the air?
Thank you, Buddy Williams.
We'll bring Buddy to talk about it.
Makes me not want to go to sleep at night.
All right. Hey, thank you, everybody. Great show today. Thank you for participating. We'll see you next time